Hello everyone, this is Naushad. I hope all of you are doing really well. Today we're going to talk about the classical physics, where the classical physics fails actually. When we entered into our ninth grade, we thought about the classical physics first. After that, onwards, we introduced ourselves to the modern physics when we entered into our HSC actually. So what is classical physics? It actually has the electromagnetism, electricity, the mechanics, like the Newtonian thing, Galilean astronomical things. Those are the classical physics actually. Okay, so also the thermodynamics is invented in classical physics, like which was not that much old, but a few decades ago the physics was invented. Like those things are considered as the classical physics. After 1900, when Max Planck was inventing or working on black body radiation, from then to now, this period is actually considered as the modern physics. So after Max Planck, Einstein, Max Born, Rutherford, then Erwin Schrödinger, Richard Feynman, Carl Sagan, these are the scientists whom actually invented the structure of modern physics. So where classical physics fails, that's the topic. So we can consider two situations. One is near to the speed of light. So that's the first condition. Near to the speed of light means light travels approximately 3 into 10 to the power 8 meter per second. That's the velocity or speed of a light. If we are approaching near to the speed of light, the time slows down. So that actually is called the relativity. Okay, so Einstein invented the relativity. So this is the universal situation. The classical physics cannot really describe this, because when the velocity of anything approaching towards the velocity of light, the classical terms and the equations cannot really describe it. Like we are actually considering a situation where we are actually calculating the momentum of photon. Okay, so we know the rest mass of photon, the light particle, is 0. Okay, so if we need to calculate the momentum of photon, that is mv and m into v, so it becomes 0. So that's not possible now, because the momentum of photon is not actually 0. So the classical physics and the equations of classical physics cannot really describe these situations. Like relativity is something the classical physics cannot really describe anything. We actually developed the relativity from Galilean transformation to the Lorentz transformation. The updated Lorentz transformation is the structure. It's made the structure of relativity. But if when we thought about developing the equations of relativity, we go through these equations and they cannot really describe the relativity thoroughly. So then we shifted to the extremely good version of Lorentz transformation for developing the equations of relativity. So these are the situation where classical physics fails. Okay, so another one is the gravity. So in atomic level, the gravity doesn't really works. The gravity which holds the entire galaxy or the orbits, the sun, moon, the planets, this gravity has a powerful strength outside the world, but inside the atomic level, gravity doesn't really works. Like we know that around the photon and neutron, which is a nucleus, the electron is revolving. So if we look down, actually deep inside an atom, the gravity here cannot really works, and in the atomic level we cannot really discover anything related to the gravity. So here, if it's applicable to the normal nature or space, it has to be applicable to the atomic level, but it actually fails. So in atomic level, there is no work of gravity. We haven't discovered it yet. Okay, so that's where the classical physics also fails. So if we look back to the history, when Bohr developed the atomic model, after that, now first of all, the Thomson developed something which is called plum pudding model. So developing plum pudding model, we got the Bohr's atomic model, which is not actually the correct thing. That Thomson was wrong. The Bohr's entire thing was not like 90% thoughts were wrong. So after that, nowadays we know the Schrodinger's experiments and the Schrodinger's equations related to atom and its shape. These are the things which is actually true, and we discovered these sort of things, or Schrodinger discovered these sort of things using the modern physics, not the classical physics. Here also the classical physics fails. We know Thomson's model like something which is inside a pudding sort of things, and inside it's something which is a nut or something. The electron is like nut. So this is not true. In Bohr's atomic model, we have also come across to the theory of hydrogen spectrum, and we see some scratches to the spectrum, and which is also not described by Bohr entirely. And also we haven't really got the electromagnetic spectrum there. So after modern physics, or using the laws of modern physics, we have got the electromagnetic spectrums. So these are also the failures of classical physics. So nowadays we have come across a lot of inventions and technologies which actually needs the modern laws, the quantum physics and modern rules, like where we actually can go deep inside anything and also explore the outside of the world. Okay, but in our basic natural phenomena, like what is happening around us is actually 90% or 95% can describe by the classical rules. But if we need to think about the universal laws, the classical physics or classical rules are not universal. It varies. Like also something when we were thinking about the time, we means that Newton. Okay, so we when Newton was thinking about time and space, he told us then that time and space both are absolute. Okay, so which is not true now. When we are approaching near to the speed of light, the time slows down. That's the relativity, and that's proved. Okay, and also the space is also not that much specific. Like when we move within a very big velocity, the length contracts, the length shrinks. So this space or length is not actually absolute. Also Newton told us that using the classical formulas, Newton told us that the time which is passing in Mars is same as time passing in Earth. It's not true now. The gravity here enters. The gravity of Mars and gravity of Earth is different, so that's why time in Mars and time in Earth is also different. We also have another example, like when we are approaching near to the black hole, so the near the event horizon or the space near to the black hole is called the event horizon, where the gravity is so high. So when we are approaching near to the black hole, we are experiencing a less time than normal day. Okay, if someone who is traveling using a rocket around or spacecraft around the black hole, he will going to experience less time, because near to the black hole the gravity is high. So here also the time is not similar as the Earth, Mars or another planet. So time varies, depends on gravity and velocity. When velocity is high, time is less. When gravity is high, time is also less. So these are the changes. These are the things which is actually true, and classical physics cannot really describe it. So there are a lot of things which classical physics fails when it comes to describe. But the basic things what we have learned about the periodic motions, the waves, the electromagnetism, electricity, gravity, the classical gravity, also the thermodynamics, these are the things which actually are pretty important for us to know. So we cannot really deny the classical physics or its impact on Earth or our day-to-day life, but we need to know more about the modern physics. Also modern physics comes from the classical physics, but the impacts of modern physics is more nowadays, and we need to know more about the modern physics. So that's why I made this video. So in near future we're going to create some extra videos related to modern physics, some modern physics rules and the scary phenomena. Thank you very much.